Hi, I'm Kevin Rollins. Today we're going to talk about a very pressing question that I think a lot of people have been asking themselves, and that is, should I become a programmer? There's a lot of talk about the big salaries that are out there, and there's lots of schools and websites and people offering ways of getting into the business with this promise of this great return. And so I think that if you're interested in it and it seems like a good fit, I think you should ask yourself, what's the best way, not just to get in general or to learn any particular thing about it, but to find a certain set of technologies that are going to actually get you remunerated for your investment sooner rather than later. And that's what this talk is about. I'm going to try to keep it to about 10 minutes. I'll probably go over. I have 17 slides, and so I'll probably not cover each of them in full detail. And I'm going to put the slide deck up on my website once I post this video. And again, at the end, I'm going to remind everybody that feel free to send me an email or put a comment on the video. I'll try to respond to any questions or comments that you have. And if I say anything wrong, please correct me. So let's get to the slide deck. I like this guy here. He's got a wall panel. I think that would be useful if I had a wall panel. Anyway, so the subtitle is Finding an Economic Learning Path to Investment Return. Again, the concept is let's reduce the path to be short enough so that whatever we put into the learning path in terms of you're making an investment, you're spending your time, perhaps you're giving up work, perhaps you're giving up other fun things you could do, perhaps you're giving up a different investment that you could be doing instead of this. And so the idea is, well, what amount of effort are you putting in and what are you getting back from it? We've heard about the big salaries, but maybe there's a smaller return for a smaller investment. I think that's sort of where I'm going with this talk. So let me get into some of my key points. These are sort of the key takeaways of this talk, and I'm going to develop why I believe these things are true. Through going through this slide deck. Just to remember that there are lots of people out there. We always hear about people trying to get into software. We do hear some success stories of people who've switched careers and may have gone to a boot camp, maybe they self-studied. But there are people who are making the transition who didn't go to school for this. And yet there are also people going back to school to get a second bachelor's degree or maybe a master's degree in computer science. So it is happening. I just think that there's actually an even greater number of jobs that are available that are in fact not being filled because even with all these people flowing into the business, they aren't qualified at the level they need to be to actually break in. And I think that's a big economic problem, actually, not just for the people who are trying to get in, but also these companies that are looking for talented and qualified people. One of the key problems is that some of the experience that's needed in these big, super scaled corporate jobs, you really can't get that experience outside of those firms. If you don't have a reason to process, 100 million queries or data profiles of customers, you're just not going to have the same kind of experience that would lead you to be qualified to do that exact job in some big corporation. And so I think that's sort of an aspect of the problem of breaking in. This talk is more focused on a second point, which goes to the underlying difficulty and the complexity that's internal to software development in general, but also in the specific ways people go about trying to build software that leads to a lot of complexity. And so let me tell you my own story briefly, and that way you can see where I'm coming from. I got into software through Ruby on Rails. Before Rails, I had used content management systems, and I had built some very simple HTML, CSS websites. A friend of a friend had a social networking project that they wanted to get built, and my friend asked me if I was interested in working on it. And I said, well, let me think about how to do this, and I found out about Ruby on Rails. And Rails has these incredible pitches for it, and this is about 10 years ago. Here on the right we have DHS. This is even from even longer ago. He made this 15-minute, how to build a custom blog application using the Rails scaffolding, and in 15 minutes he goes ahead and builds it right before your very eyes. I saw that, and then I took this little course called Rails for Zombies, and it's very compelling that if you learn to use Rails, you can pretty much build whatever you want. It's very alluring, and so I told the client, yeah, I can do your project for you. I'm going to use Rails, but boom, Rails isn't that simple. It's not as simple as even just knowing how to use the basis of Rails. It's actually understanding the environment in which Rails is dealing with. And I love this chart from Codefellows. Codefellows article, "This is why learning Rails is hard." And we won't go into all the details of this chart, but I recommend going to their website and checking this out and zooming in on all these pieces if you want to check it out. Basically, over here, this blue branch is anybody who's going to be learning anything on the web development needs to know this www tree. It includes HTTP, which is the hypertext transfer protocol, which is how we communicate with websites. Basically, that's the protocol for that. HTML, which is the markup language which websites are written in. CSS, which is a language for describing what websites look like. And then JavaScript, which is a programming language that runs in your browser, which allows websites to be interactive. So basically every web developer needs that. But when you get into Rails, yes, you do need to know all that also, but Rails has its many levels of complexity and its own paradigms, including model view controller, RESTful APIs, ORM for dealing with databases, as well as a bunch of specific aspects of how Rails works internally. But to even get Rails working, you need to have Ruby gems installed. And Ruby gems is a Ruby project, and Rails is written in Ruby, and so you also need to understand the complexities of the Ruby language. So again, Ruby on Rails is not just a singular thing, it's a multifaceted piece of tooling, and it interacts in a complex environment. It runs inside of, say, a Linux server, and in Linux you have a command line, and you have package management, and all the details of dealing with that environment. And so you can very easily see that if you want to really understand how Rails works, there's a lot more puzzle pieces to fit in. To take this point just a little further before we get into the main line of the talk, to sort of think about the layers in which the world of programmers, the world in which they live in. You have disciplines like computer science, which involves discrete math and algorithms, computer organization. In terms of operating inside of a software team, you have agile project management technologies like Scrum and these ways of running your team and way of dividing up work. You have testing and verification of the software. And even within the world of programming, you have high-level programming, which is thinking about how to design object-oriented systems or purely functional paradigms. You have low-level programming, which involves optimizing for given resources, moving things around in memory and such. And then, in order to operate in this modern world, you have to deal with the cloud environment. So big companies that want to scale their products use things like Amazon Web Services, they use Azure, they use Google Cloud, and while these technologies are really truly amazing, it is actually its own skill set to know how to even use the GUI interface for these things. And then there are domain-specific languages inside of these systems for provisioning resources. And so, learning that could take a couple of years of your time, especially if you were self-studying with no mentor. So that's just. By the way, that's just the first page of depth. I have another page, which we won't go into all the details of this, but there's the internet and networking. How do systems talk to each other? What is an operating system? And How do you as a user use an operating system? How does the system itself work? And then how does that work in terms of the hardware? And what does the hardware do? And understanding how a computer works and what everything that your program is doing relies, to some degree, at least on a model of what it's all about. So that's all just to say that, wow, it's a lot more complicated and deep than, let's build a blog in 15 minutes. Let's get back to this concept of dependency. So a dependency is a requirement, basically. A requirement either of your knowledge or of some tool stack. So, for instance, in terms of your knowledge, to be able to do machine learning intelligently, you actually need to know linear algebra and calculus pretty well, because machine learning is designed in those languages. And then, in terms of tooling, just setting up Ruby on Rails requires that you first install Ruby, which then before that requires RB and env, for instance, which is a Ruby language installer. And so frequently you will have this where solving one problem requires solving another problem first, which leads us to this idea of Yakshaving. Programmers love talking about Yakshaving. What is Yakshaving? Basically, a technical way of saying it would be that Yakshaving is the recursion of dependencies. And having too many dependencies basically means that as you keep stepping down the tree of what you need, it seems like the time it takes to get something done approaches infinity, basically. A good example of a good way of understanding sort of how this feels in the real world, and I think this actually captures really what a software developer's day is like. Let me read you just a couple of sentences of this great blog post it has me through. It says, say you want to go see a movie with your friend Joe. You can't get away with leaving the house when the kitchen is such a mess, so you have to load and run the dishwasher before you go. Unfortunately, you're out of detergent, which means you have to run to the store to pick some up. You want to ride a bike, or it will take too long to get to the store. But your bike's front tire is kind of low, so you have to pump it up first. However, your roommate borrowed your tire pump and you don't know where it is, so you have to go find your roommate. ... This is all too real. Another great visualization of this concept is this scene from Malcolm in the Middle, where a much younger Bryan Cranston is trying to fix his light bulb. So when you're done with my video here, go watch that. It's pretty funny. So to come back around to this point of getting to economic return, let's think about what economic return is. Value is created when a product is delivered. And when somebody who is either observing what you're doing appreciates it, or they themselves can use what you've built to make money somehow, or to provide a service or value to somebody else. It has to create something in the real world. It has to give someone a laugh at least, or give someone an ability to learn something in a more effective way. That's value. So given that idea of trying to get to the value, what can you learn that has a minimum number of dependencies that will give you a useful skill that will enhance your productivity or create value with the minimum number of steps? So the whole question is, how can we make it easier to go from wherever you're at today to some kind of productivity? So this leads us to a way of simplifying the problem a little bit. What if the problem is that we're talking about, if we're trying to solve the problem, how do you get into work for Google? How do you go to work for Amazon? How do you go work for some Fortune 500 company and work on their already developed gigantic tool? Or how do you get into the startup with the super wizards? Maybe that's the wrong question. Maybe that's not the goal. And yes, it may seem like the $200,000 year salary is very exciting, but is that really the goal? What if we redefine the problem as simply, I want to be able to build database-driven websites, which is sort of the problem that Ruby on Rails says it's going to fix for you. That's the reason why I got involved in it. So let's redefine the problem, not as like let's make Google want to hire me. Let's just make it so that I can solve some particular problem. And when you think about it in that term, when you reframe the problem like that, the problem is a lot easier to solve, and it actually gives a pathway to determining what technologies are going to give the best return for the investment. To make the point once again, get the productivity with less investment. 1, reduce the areas of knowledge that are required. 2, reduce the number of tools involved. So here's my proposition for the would-be developer. It's a beautiful lamp. It really is a beautiful lamp. It warms my heart to see that lamp. And that lamp is Linux, Apache, MySQL, PHP. It seems very simple. It seems very basic, but it actually is a great opportunity for someone who is just starting out. Lamp stacks are easy to set up. You can even get a package like WAMP or MAMP or XAMP that will just put all these pieces together on your machine, and you can just go to work. If you're running Linux or Mac, it's pretty trivial to install it from the command line. The beautiful thing about this also is that once you are ready to put something online, a lamp stack is inexpensive, and they also come with a lot of things that are configured already. Like, you don't have to build your own mail server. You don't have to set up your own backups. You can pay $10 a month, and this will work out of the box for you, and get all the things you need without getting into something as complex like as Amazon Web Services. Again, Amazon Web Services is totally great, totally awesome, but you don't need it. It's adding a lot of complexity to your life that does not directly make you a better programmer or add more value to your local customers. And so the other benefit of this is not only is it simplifying what you have to do to get started or to deploy your software, now all you have to do, this is the total minimum set of things to learn, is basically learning PHP and MySQL. You don't even have to learn JavaScript to make a database-driven website using PHP and MySQL. JavaScript might make the website better, but you can actually build a totally database-driven website with just PHP and MySQL and some very basic HTML. You don't even have to learn CSS. Although CSS, again, like JavaScript, it makes it nicer. So LAMP is really a great solution, I think. And again, I ask, think about, it's not as sexy. It's not doing data science with Python. It's not the newest, hottest, fastest thing like Golang or Scala or any of the other things that people are using. But it is a practical solution. And looking back at my technical path, I kind of wish I had done something like this. I just didn't realize, of course, the complexity that I was getting into when I got into Rails. I think I probably would have accomplished more in my time spent if I had started with something like this. So that's why I so strongly recommend this. So going forward, to talk about MySQL and PHP. 1, again, it's easy to start learning. 2, very quickly after you've learned these things, you can actually put them to work in widely used tools like WordPress, and increasingly this tool called Processware, which is really better than WordPress, but it's not got the market share. But basically, these are tools that people are using. A lot of people who don't have any idea about how coding works. And so now with PHP and MySQL, you can actually get into this code, and you can change the functionality, you can improve the functionality, you can add features, and that is an immediate benefit. And surely there's a small business near where you live that needs help with a tool such as this, and being able to use this puts you a step above people who are just merely web designers. You're actually a programmer. Moreover, learning PHP, you can do all the high-minded coding practices. You can learn object-oriented design. You can learn testing. You can practice version control. you can focus on learning the language. And actually, PHP, if you know PHP, learning Python or Ruby or Java or C, for that matter, is not that much of more of an effort. And so it's a doorway to that. Furthermore, SQL databases are pretty much universal. There are a bunch of new NoSQL databases that are being used. But if you know SQL, even if you're looking for a corporate job, that's a pretty good credential. And surely, if you're using some other technology in the future, there's a good chance you'll be using SQL with it in some form or another. So these are immediately useful, and they are useful in the future. So I think that's another sales point. It's a doorway that leads to an outcome which is not dead-ended at this limited thing. It's a tool that can be used for bigger and different kinds of projects. So I propose for someone getting into this to think about it like a 3-stage learning path. The first stage is we just talked about. It's the PHP and MySQL base, and then learn enough HTML and CSS to basically make the website function and be attractive. The HTML and CSS are pretty simple. The CSS is sort of limited by your own creativity. And that gets you to adding these functionalities to these off-the-shelf tools. Second stage is JavaScript. Learning JavaScript really well, learning how to visualize data, create interactive pages, create browser-based games, and that JavaScript itself is another great job skill. And again, now you have JavaScript, PHP, and MySQL. You can build really nice database-driven websites with these 3 tools. Then, if you want to go one level up, and again, still staying with your shared hosting, LAMP stack simplicity, you can start building JavaScript's got a library called React from Facebook, and that's built for building front ends, like a single page websites, and you can make that talk to CodeIgniter as an API. And CodeIgniter is a PHP library, a PHP framework that will run inside of shared hosting, and it's pretty simple. It's actually simpler than Rails, I would say, in terms of how it works. But you can do basically anything you can do in Rails, you could do in CodeIgniter. So, again, how long would this 3-stage learning path take? I would say between 6 months and a year. Thinking like 2 to 4 months for each of these stages. And again, there's a return after the first couple of months, because now, wow, you know PHP and MySQL. That's fantastic. And this is thinking about doing like 10 to 20 hours a week of work on it. Obviously, if you work if you don't work as hard on it, you'll make less progress. But again, within 6 months, you could surely, even if you're working only a couple hours, every other week, you could learn basic PHP and MySQL in 6 months. And that's when we do the next version of this. I'm not gonna say it like that. All right, so we're coming here to the end of this. I think I've gone way over my time. Some learning strategies that I think we should consider. I think these are good learning strategies for anybody who is trying to pick up a language. Iterating your practices. Practice every day, and at least an hour every day. And even if your hour is only 20 minutes, put in your daily hour. That's sort of a cheat. Memorize keywords, memorize method names. Know what's in the language. Just to know what's in it will help you have options for what you can do. And you're like, oh, what about that thing? Do I know how that works? Let me go look at the signature of that function. Let me go plug that in and see what happens. And that's the third part, is experimentation. Just simply take the tools that are given and play with them and see what happens when you do different settings, or see how it breaks in different ways. You're not going to get fined for breaking a PHP program on your own computer. And then once you're feeling confident with the language, start going around and looking at cool websites and seeing what other people have done that you like, and try to create a scrapbook. And then maybe as you have time, try to build your own version of these things that you've seen, and see what you can do with your current knowledge, and then try to figure out what what knowledge you would need to actually fully implement it. So that's the talk. If you're not fully sold on it, I understand. But if you enjoyed the concepts and you'd like to see more conversations about technology, economics, and learning, I'd be happy to produce more episodes. I'll be getting better at doing this screencasting, hopefully. Just like practicing, I keep practicing, and doing the recording in one go is a little bit difficult. And not feeling too shy, and I'm just here myself in my office. There's no reason why I should feel shy, right? So I should just keep practicing until I get it right. Just like you would if you were learning PHP. So please like and subscribe, and if you put a comment below, I will try to pay attention to that and comment back to you. At some point, I'll have some contact information up on my website. Finally, I'd like to thank some people who've created some great free and open source software that I used in producing this, including my operating system, Fedora Linux, and LibreOffice Impress, which is how I made the slides. And I produced this video in OBS Studio, which is a screencasting tool. Very excellent. Thank you for listening, and I hope to see you next time.